Howdy, howdy, howdy. We're talking assignment 7. Let's mark this bad boy right now. It says make a model or a diagram to show each improper fraction as a mixed number. So looking at this improper fraction, the denominator is what I'm paying attention to first. And it's telling me how many parts should be in one whole. So 4 parts, 4 parts. Cool. But now I'm dealing with an improper fraction, so I know I'm going to have to make more than one of these shapes because improper fractions are greater than 1. And this improper fraction is actually quite large, so I'm going to have to make a whole bunch of whole shapes here. Now I'm trying my very best. It's not perfect, but I'm trying my best to make these shapes the same size. That's important. Otherwise, each quarter that you're making here, each fourth, will be different, and that's just not good. Okay, let's make one more just for fun, just to be safe. If I make extra shapes, that's okay. I just won't shade in any more than I need to. Okay, actually, I lied. I'll do one more just for fun. Because that's fun, isn't it? Woo, yeah, I'm having fun. Cool, okay. So I've got a whole bunch of fourths and a whole bunch of holes. Now let's do some shading. I need 17 of these shaded in. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 fourths. Boom. There's 17 fourths represented visually with a model. But now the question's also asking me to say, what are these improper fractions as a mixed number? Well, that's actually pretty darn easy now that I've made this model. All I have to do is count my holes. 1, 2, 3, 4 holes. And I've got 1 out of 4, or 1/4 left over. So 4 1/4. That's equivalent to 17 fourths. Kind of neato. Cool. Now, since you just saw me draw that one out, I'm not going to make you wait and watch me, so I'm going to pause it for each one of these. Boom. Okay, here are a bunch of blank empty holes. I need 9 quarters. So 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 quarters. What mixed number is that? Well, I see 2 holes and 1/4. So 2 1/4 is equivalent to 9 quarters. All right, so this one we're talking about sixths. You could have made like circles or you could have made rectangles. It doesn't really matter, just as long as each of your sixths is the same size. I use hexagons just because that's what we've been using recently. So I need 13 sixths shaded in. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. 13 sixths. What is that as a whole number? I've got 1, 2 holes, and 1/6 left over. 2 1/6. Easy peasy. All right, so I just made a whole bunch of blank empty holes. I've divided each hole into 8 parts because that's what my denominator told me to do. My numerator is telling me to shade in 11. So 3, 4, 5, 6, 7, 8, 9, 10, 11. Cool. So there is 11 eighths. Notice, like, I drew this extra hole. I mean, yeah, it was kind of a waste of time, but hey, whatever. It's not hurting me to draw this extra hole. I don't have to shade anything in because I've already shaded in my 11 eighths. Okay. So anyway, 11 eighths, there it is as an improper fraction. What is that as a whole number? I've got 1 whole and 3 eighths. So 1 3/8 is equivalent to 11 eighths. Neato. Moving on. Question 2 says Nicholas used 17 half circles to form a stained glass window. How do you know he formed between 8 and 9 whole circles? Well, I'm going to switch this forward to Mathagon just because this gives us some pretty great visuals. Okay, so I said great visuals, but I can't find a half circle here. So we're going to use half a hexagon. We're going to pretend this is half a circle. Cool. So they said that there's going to be 17 of these bad boys. Holy smokes. Well, we have to remember when we have half of anything, all it takes is 2 of them to make a whole. Okay, so if I had the number 4 and like they said, hey, you have 4 halves. Cool. I know that is going to give me a whole number because each half has a partner and it makes a whole, right? Same thing with any of these even numbers, right? If they said, hey, give me 10 half circles. Okay, well, there's 8. There's 10 half circles. I know that's going to give me a whole number. I've got 1, 2, 3, 4, 5 whole numbers because each of those halves combine. But as soon as I have an odd number, like 3, what would that look like? Well, now I've got 1, 2, 3. I know I'm going to end up with a half all on its lonesome because it's an odd number. Same thing with the number 5. One, 2, 3, 4, 5. I've still got one guy who's on his lonesome. Oops. Pardon me. Okay. And I think you're starting to see it. Okay. I mean, like if we had 7 halves, 1, 2, 3, 4, 5, 6, 7 halves, there's always going to be that odd half that's all on its own. Okay. So with 17 half circles, let's just take a look and see what that would look like. So right now I'm at 2, 4, 6, 7. Shoot, pardon me. There we go. What are we at now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay, I still need a few more. So we are at 13, 14, 15, 16, 17. Cool. So I know that this is going to make in between 1, 2, 3, 4, 5, 6, 7, 8. It's in between 8 holes and 9 holes because it's an odd number. When I'm adding halves, I would rather have an even number because we always have a pair of halves that go together to make a whole. So anyway, how do I know it's going to be in between 8 and 9? Well, I know 16 times 2 would give me 8. And 9 times 2 would give me 18. So of course, 17 is going to be in the middle. Okay. And then it says, write a mixed number to show the number of circles he formed. Well, check it out. 1, 2, 3, 4, 5, 6, 7, 8. 8 holes and 1/2. 8 and 1/2. That's equivalent to 17 halves. Which makes sense again, because we remember that this is just division, right? Fractions are just division. 17 divided by 2 is 8.5, which is the same as this, 8.5. Kind of cool. Moving on. Question 3. Model each improper fraction using pattern blocks. The yellow hexagon is a whole, the green triangle is 1/6, etc., etc. We know this. Write the equivalent mixed number for each fraction. Okay, so I'm going to build each one of these. I won't make you watch, and then we'll just flash back and forth. So 10/6, pause, presto. We're talking sixths, so of course we're using the 6 little triangles to make one whole. We've got 10. What is that as a mixed number? Well, I can see it. I've got one whole, and I've got 4/6 left over. Cool. So there's your question, or your answer for A. B is 14/6. I'll do that really quick, just because we're already there. Okay, so now what do we add here? We got 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so 14/6. What is that as a whole, or rather a mixed number? I've got 2 holes, and I've got 2/6 left over. Kind of cool. Okay, moving on. 11/3. Okay, we're talking thirds. We know that these are thirds because 3 of them add up to make a whole. We've got 6/3. We've got 12/3. Oh, we don't need that many. We need 11/3. So there you have it. What is this as a mixed number? 2 holes and 2/3. Moving on. The last one here is 7/3. I'll just use this diagram above it. 7/3. Let's erase some of this stuff. Oh boy. 1, 2, 3, 4, 5, 6, 7, 8. And hey, you know what? Look at that. I did this one wrong. I'm going too quick. I apologize, guys. See, that's why you take a little bit more care in your work, Lewis. Anyway, I apologize. This is wrong. Be careful, Lewis. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yikes. That is actually not 2 2/3. That is actually 1, 2, 3 holes and 2/3. Yikes. I'm sorry about that, guys. Now let's use these diagrams to help us with this one. So 7/3, 1, 2, 3, 4, 5, 6, 7. So what is that one? Well, I see 2 holes and 1/3. There we go. Cool. Okay, moving on. How does this picture, this one, show that 7/6 is equivalent to 1/6? Well, there's a few ways you can answer this. First way is saying like, well, hey, I see that these holes are split into 6 parts, so the denominator is 6, and there are 7 of them shaded in. That's your answer for the improper fraction, right? 7, 6 are shaded in. But for your mixed number, you can say, well, hey, I noticed that 1 hole is shaded in, and then there's also a 6 added on top of that. So that's how this picture is showing both the improper fraction and that mixed number. Moving on. This one, it says write an improper fraction as a mixed number. So if you really want to, you can draw diagrams or whatever, but again, that takes too much time. Let's use the second method of converting them, and that's using division. So how many times does 4 fit into 18? Oh, geez, that's kind of a tough number. I can count by 4s. 4, 8, 12, 16, 20. Okay, 20. How many times does 4 fit in 18? Well, 1, 2, 3, 4 whole times. And then what would be left over? Well, 18 take away 16. Okay, well, that'd be 2 left over. And then my denominator stays the same. 4 and 2/4. All right, cool, we're cooking. 23/5. Okay, well, I'll count by fifths just to be safe. 15, 20, 25. Okay, how many times does 5 fit in 23? 1, 2, 3, 4 whole times. What's left over? Well, 23 to take away 20. That would be 3/5 left over. Okay, 5 fits into 13 2 times, 2 whole times, and 3 would be left over. So 3/5 rather. And last but not least, 26/3. Better count by 3, skip count. And of course, we call these multiples. We remember that. We're listing the multiples of 3. 18, 21, 24, and 27. Okay. So how many times does 3 fit into 26? 1, 2, 3, 4, 5, 6, 7, 8 whole times. What's the difference? 26 take away 24. Well, that is 2/3 left over. Cool. There you go. Make corrections if you need to. Okay. I think we're on the last couple questions here. My goodness, we are. Okay, so it says a timer goes off for every quarter hour or 1/4 or 1/4 hour to remind Kenny to baste the turkey he has in the oven. Otherwise, that turkey's going to get dry. We don't like it. All right, I just realized that I had erased a few things there. I just fixed it. Sorry, yours will look like this. Anyway, question 6. A timer goes off every quarter hour to remind Kenny to baste the turkey he has in the oven. So part A says list the quarter hours on the number line below. So starting at 0, 0. Okay, and I gotta list every single quarter hour. So I'll start with first quarter, second quarter, third quarter, and so on. And presto, boom. So there's my number line. I built it. I used a whole bunch of pretty colors too. Cool, why not? Anyway, part B, it says, if the timer goes off 13 times, how many quarter hours would that be? Write that value as a mixed number and as an improper fraction. Okay, well, cool. We'll check that out. How many quarter hours would that be? Well, the way I wrote my number line, it already told me the improper fraction. I've got 13 quarters. All right. But then as a mixed number, how the heck am I going to do that? Well, I can convert it, and I could just say, hey, I know 4 fits into 13 3 whole times, and I know that would be 12, so 13 take away 12. That'd be 1/4 left over. I could do that. That's awesome. But this number line, we can use it to help us as well. And remember, anytime the numerator equals the denominator, so 4 over 4, that's equal to 1. You can also think of it as 4 divided by 4 is 1. Well, let's jump ahead another 4 quarter hours. 1, 2, 3, 4. So that's just like my second hour. That's my second hour. And we can also prove that 8 divided by 4 is 2. And it makes sense that I have to go 1, 2, 3, 4 jumps to get to the next whole hour because we're talking quarters, right? 4 jumps for 4 quarters. So that's 3. 12 divided by 4 is 3 whole hours. And then what do I have left over? 1 more quarter. So I made it 3 whole hours with a quarter. So 3 hours, 3¼ hours to base that turkey. Okay. Cool, moving on. Question 7. It says use an improper fraction to describe the number of hours. You would need to watch a 3/4 hour video 3 times. Use the number line from number 6 to help you. Okay, let's have a look here. So a 3/4 hour long movie. Well, I know that that's going to be 1, 2, 3 jumps. So I landed there. I'll do another 3 jumps. 1, 2, 3. Okay, and I'll do another 3. 1, 2, 3. Okay, so that's where I ended up. I watched that 3/4 hour long movie 3 whole times, and that gave me 9 quarters. Okay. As a mixed number, 4 fits into, well, I'll use the number line. How many whole times did it go? Well, there's 1 hole, there's 2 holes. And what was left over? 1/4. Cool. And also because 4 fits into 9 twice, 2 whole times with 1/4 left over. B, how do you know that your time in part A is equivalent to 2 1/4? Okay, well, I've already said it. But again, it's because I went 1 whole time, 2 whole times with a quarter extra. Okay. Awesome. Okay. Well, thank you for watching this. Thank you for making any necessary corrections so that you have great study materials and so you've learned from your mistakes if you made any. Good luck. Happy studying. Smell you later.